just a reminder, during the holidays, Watobe continues, and we're going to continue with functions, guys. So in the holidays, we're going to do exponential, we're going to do hyperbola, we're going to do trig functions. So we're just going to keep mastering this topic of functions. And if you build it a solid foundation, I promise you, it's actually a really nice section. So that is where we're going. Okay. Okay, so I want to know, to start today, what is the 5-step process for drawing a parabola? We did this in the last lesson, and I want to know from you, what is the 5-step process? Let's get the show on the road. In the chat, who can help me? Happy or sad? Yes. So happy or sad, I will just put a happy face here. Step 1 is happy or sad. And we know that by looking at the A value, okay, in the standard form of a parabola. Actually, also in the alternate form, but we'll get to that. What about step 2? Step 2 was the y-intercept, which we found by making x naught. Yep, I see Teddy's mentioned something called symmetry. Which step was that, Teddy? What's step 3? Okay, so step 3 is the x-intercept. We make y equal to naught. Step 4 was finding something called the axis of symmetry. And I often abbreviate it by writing A/S. Basically, in a parabola, in grade 11, your parabolas don't have to be cut in half by the y-axis. Sometimes they're cut in half by a line like, for example, x is -2. We call this line the axis of symmetry because it divides the parabola into 2 equal halves, and the turning point will, oh, it's not a very good parabola, but the turning point will always be on the axis of symmetry. What is step 5? Actually, no, hold on, wait. What is the formula for finding the axis of symmetry? Who knows that? It's also got B's and A's and things. We're going to need it for today. Kaklejo, you're on the money. It is x is minus b over 2a.
Wow, this class is on fire.
On fire, where the b comes from here and the a comes from here. Something else to point out, everyone, is the axis of symmetry is actually, well, this makes sense when you think about it. It's halfway between the 2 x-intercepts. So actually, sometimes if you don't, it's normally quicker to use the formula minus b over 2a. But you also could say, if I've got the 2 x-intercepts, if I just add them together, so for example, if I go x-intercept 1 and x-intercept 2, and I divide them by 2, then that would also give me my axis of symmetry. But most students like just using the formula. And then the last one is the turning point. And how we get the turning point is we just sub basically the axis of symmetry value, we sub it back into the original. So it's easier if I show you this, but basically, if I had like x is 3 as my axis of symmetry, I take 3 and I put it back in the original and I get a y value out. And whatever that y value is, together they make up the turning point. So what I do when I draw my parabolas is I always do my working out first, and then I go and draw my graph. And that's what we're going to start with today. But if you need to take a screenshot of these 5 steps, do that now, because you will be using this a lot today.
I'm so proud of all of you. Oh, they were so on fire. They knew all this.
Yeah. Give us a thumbs up if you've got the 5 steps. If you've got the 5 steps and you feel like you know what they are. Ituma Leng says, what's the difference between a turning point and an axis of symmetry? So the turning point has two coordinates. It's got an X and Y part. So basically, a turning point is literally where the parabola turns, and its X value is the axis of symmetry, whereas the turning point is the X and Y values together. It's a whole point. Whereas, does that kind of make sense? You'll see it when I do examples today, but basically the axis of symmetry is just part of the turning point. The turning point will always be on the axis of symmetry. Okay, so in the last lesson, when I left you, I'll come back to that later. When I left you, we had got to this stage over here, and we were trying to draw the graph of, let me just close this. We were trying to draw the graph of y equals x squared minus 6x plus 8. And when I left you, there were still two more steps to do. Now, we'd found that it was a happy graph, so that was good. We found the y-intercept. We found the x-intercepts. And now we needed to find the axis of symmetry and the turning point. So I'm going to do this one as an example for you, and then you will do the next one. And so just watch my technique here. So in order to find the axis of symmetry, I'm going to go to my original and go, what is b? It's minus 6 over 2 times 1. And so we get 6 over 2, which is 3. So now we know the axis of symmetry is x is 3. Now I'm going to take that back to my original, and I'm going to sub in 3. So I get, oh, it's not a plus. It is a minus. I put a 3 there, and I put an 8. And because it's late at night, I'm going to make sure I use my calculator here. I get 9 minus 18 plus 8, and I get minus 1. And so my turning point is going to be 3 minus 1. And let me just double check my work. Minus, yeah, that's fine. Okay. Give me a thumbs up if you agree with me that you have 3 and minus 1 as your turning point. Okay, so it's time for us to take all this hard work and translate it into a graph. And guys, when it comes to exams and you get a question like this, you're going to be like, give it to me, because you have your working out done. Drawing the graph is simple. Now, normally they provide you with a Cartesian plane, but if they don't, you can sketch it yourself. And I know I haven't done this perfectly, but basically we have X and Y. Now, what I do is I have a slightly different technique for parabola. I put my axis of symmetry in first. It's almost like it divides my graph up. Now, my axis of symmetry was X is 3. So I go 1, 2, 3, and I'm literally going to draw a dotted line and label my axis of symmetry. And it's almost like it is getting my everything in order here. Okay, now, the next thing I want to point out is I need to put dots for where it's going to cut the axes. So I'm going to label y is 8. So let's go 1, 2, 3, 4, 5, 6, 7, 8. That's my y-intercept. And my x-intercept was going to be 4 and 2, or 2 and 4. So let's go 2 and then 3. It's going to be there. Now, notice how I still haven't labeled my turning point. My turning point was at 3 minus 1. And so 3 minus 1, I'm going to go 3 across, but I know it's on the axis of symmetry. I go down by 1, and there is my turning point. So I've labeled what I call all the important points. It's now time for me to put my shape. How do I know what the shape is? Step 1. Step 1 is a happy graph. So I start at my turning point, and I have one side of my smile there, and then I have another side of my smile, sorry guys, not perfect, that goes like that. Now, if I wasn't in digital land, I think I would have done that better, but you get the basic idea. You fit both sides of the smile into the points that you've labeled. Now, what have I forgotten to do that I need to do in order to get full marks for this? Tell me in the chat. I've left something out. I need to do something still in order to get full marks for this question. Okay, I need to label. So if it's just said label, if it says coordinates, I do full coordinates. Here I'm going to say, I'm just going to label it. Normally I label that 4, I label that 2, I label this one over here 8. So those are the intercepts. And then the turning point, you always have to label the full point. And the turning point was 3 minus 1. And then the last step is I just need to label my parabola. So what are the steps? Step 1 is do all the working out. Okay, so that is the 5-step process. Then when we come to drawing our graphs, we do the axis of symmetry first. We then do our points. We then draw our graph. And we then label everything. Now, I've thrown a whole bunch of work at you guys. So what we need to do is we need to practice. But before I do that, for those who want to take a screenshot, please take a screenshot now. And then if you are feeling very confused, I'm going to give the class a chance to practice now. If you feel confused, please ask a question and I will assist you as best I can. Okay, let's go and do example number 2.
Can I just say that the graphs, guys, the way that teacher Peter drew the graph, you see that it's curvy. It's not like straight line graphs. Yeah. Sometimes we get students drawing the graph as straight lines, like legitimately drawing a V. So that will be wrong.
So the shape should be, it must have curvature. It should actually look, this should be going straighter up, but I just, for the sake of time today, I'm not going to stress too much about that. But what I first want to do is I want everyone to do the 5-step process. Let's do this in 2 steps. So you guys do the first 5 steps for me, and then I'm going to give you feedback. And then after that, I'm going to let you start drawing the graph on the other side of the screen. Okay, so over to you guys. Me and Yolanda are just going to be here to support you and help you if you get stuck. But basically, it's over to you for at least the first 5 steps.
Yep. Ralida is asking if we could go through the steps. I just want to say that when we do correction, teacher Peter will definitely go through the steps again. So
I'll give a little hint.
You can catch up.
How about if I give you those hints? Those are my hints for you. And I'm going to get some water because, and then if there are any questions, please put your hand up and we will assist.
Let's do this, guys. Let's do this. While we edit, guys, have you heard about Martina? I'm just being naughty now. Focus.
Now, there might be some unexpected. Let's have a look 2 times.
Let's do number 1, 2, 3, 4, 5. Let's go, guys. Really, it's gonna help you a lot because this is like 6 marks on the bag.
No.
For free, guys. Let's do this.
Oh, this is going to have, okay, there might not be yeah, I will. It is possible to have no x-intercepts. I haven't checked this, but I suspect that may come up, and I'll explain it to you in a moment when that happens. But let's just see if I'm correct or not.
I think Susanna is on the same page. She's like,
yeah, okay. So if you can't solve for x, what that means, Susanna, is it means that there are no x-intercepts. So just keep going. I'll explain to you now. That's often why I check delta first. If delta is negative, then it means that there are no x-intercepts. And there are some parabolas that have no x-intercepts. And I'll explain to you now what that looks like. Luckily, the process handles it just fine. Okay, so I see some people are putting the axis of symmetry in, which is sounding good. We'll go through that in a second. Keep those answers coming. If you get no x-intercepts, or if you get the equation being undefined, or I'll talk about that now that you're correct. There is no, but I'll explain that to you now. Nontokozo, I agree with you. Your y-intercept looks good to me.
You guys are really doing well. Woo, someone has hit again TP already.
Okay. What have we got for turning points coming in here? Let's have a look. So what I will say, guys, is when you try to solve this equation, you will notice that you get stuck. And I'll explain now why that is. But what it really means is that there are no x-intercepts, which will be revealed in time. But what is the axis of symmetry? Tabello, it's not actually possible, even if you move everything across. But let me explain that in a moment. Let's just get the turning points first. Okay. So think about what is, at the moment, we get -2 over 2 times -1 minus b -2 over 2 times -1, which is, I get x is 1 as my axis of symmetry. And what do I get for my full turning point? I have to sub that back into the original. So I go, what I like to do is I leave a space for what I'm subbing. And I'm subbing this 1. So take a moment to see. We know that the axis of symmetry is minus b over 2a. And if I imagine that a is -1, b is 2, c is -3 in this question, I get, if I take the 1 and I sub it back into the original, I get -1 plus 2 minus 3. And that will give me -1 plus 2 is 1. I get -2. And so my turning point is I get 1 minus 2. Okay, so let's just take a moment to make sure we understand what's going on here. In this question, when I applied the formula x is minus b over 2a, I ended up with getting x is 1. I then took the x as 1 and I put it into the original equation. And if I did that correctly, sorry guys, purple's not the greatest color, is it? I should have used like a yellow or something. Let's bring it back. So this x is 1. It goes into the original equation. Notice I'm saying minus x squared plus 2x minus 3. And when you do that, you end up with a minus 2. And together, these give me 1 minus 2. Sorry, non to cause. Okay, so let's go through this. We can all see that this is an unhappy parabola. No problems there. If I make x is 0, the y-intercept is minus 3. Basically, these two terms get knocked out. No difficulty there. Something weird is happening when I try to find the x-intercept. And I need to tell you a little bit more about this. So what we do is we go 0 equals minus x squared plus 2x minus 3. And can you remember I told you in the last lesson, it's not wrong to factorize, but the formula is your friend a lot of the time. And whenever I am going to use the formula, I have to know what the formula is, which is this thing. But I like to know what delta is, because delta tells me a lot about this question. So delta is just b squared minus 4ac. And if I see delta is negative, I actually know not to waste any more time. So let's see what I get. B is 2, so I get 2 squared minus 4 times minus 1 times minus 3. And what I'm going to get for that, 4 minus 4 times minus 1 times minus 3. Guys, I get delta is minus 8. If delta is negative, you cannot solve this equation. So if you cannot solve this equation, what does it mean? It means there are no x-intercepts. So can you guys, I want to make sure you understand this. Do you understand that if you try to solve for the x-intercepts and you get, the formula says delta is negative, it means there's no x-intercepts. Give me a thumbs up if you understand that. So if you try to factorize this, you made a mistake in your factorization because it's not possible. And so guys, this is why I'm such a big fan of the formula, because the formula tells you the truth no matter what. If, for example, there are roots, delta will be positive or 0, and you'll get your roots. Okay, a lot of people don't understand that. So let me say it again another way. Whenever you are solving for the x-intercepts of a parabola, you always start by replacing the y with a 0. Then you have to now solve a quadratic equation. My recommendation is to use the quadratic formula to solve that equation. When you start solving this equation, if you find that the thing inside the square root bracket, what we call delta, if it's negative, it means that there are no x-intercepts. Okay. If delta is positive or delta is 0, then there will be x-intercepts, and you'll find them by using the quadratic formula. Okay, so that is a bit of a tough one, but it's going to get easier as we do more examples tonight. So let me just draw this equation to show you that my method still works.
Teacher Peter, sorry, is it fine if you can emphasize where did you take your delta? Because it looks like this delta here, it's getting confusing. They don't really know where it comes from. And that's
okay. All right, let me highlight that together. Thank you for that, Yolanda. In our 5-step process, I am focusing on step 3, where it says, let me see if I can, I'm sitting here, and basically I'm saying 0 equals minus x squared plus 2x minus 3. And I've taken that equation and I've simply moved it to the top here. Okay, so that's where it came from. Then I started trying to solve it with the quadratic formula. And part of my process of solving it was to work out delta. Now, delta is this thing in yellow. And I found that delta was negative. And if delta is negative, it means that basically, guys, do this with your calculator. Type square root minus 8. Type in your calculator and what do you get? What's the square root of minus 8? I want someone to tell me in the chat. Or to come online. Undefined. Math error. Perfect. Perfect. So what I want to show you tonight is that when you have delta being negative, you cannot find the square root of a negative. That is why we come back to the idea that it means there's no x-intercepts. All right, give me a thumbs up if that makes a little more sense now. Give me a thumbs down if you still feel like, oh my goodness, I don't know what's going on here. But you can still draw the graph, eh? You can still draw the graph. So let's go and do that. So what was my first step in drawing the graph? I'm going to do this one for you guys. It was to put my axis of symmetry. And my axis of symmetry was just x equal to 1. Now, we don't have any x-intercepts, but we do have a y-intercept. So the y-intercept was at minus 3. 1, 2, 3. So the y-intercept was down here. And where was the turning point? The turning point was at 1 minus 2. So where is 1 minus 2? It's going to be here, and it's going to be down, so it's going to be over there. So the y-intercept was at minus 3. This is at 1 minus 2. Now, guys, can you see that there's no other extra points I need? So what's going to happen is I'm going to fit my shape just through those 2 points. So watch this. It's an unhappy graph, and the highest point it gets to is that blue one. And then it goes down like this. Can you see that this graph never ever cuts the x-axis? So give me a thumbs up if you see why it never cuts the x-axis based on the drawing. So that's why when you were solving for the x-intercepts, you would never ever get an answer for that. Okay, the last step that we need to do is we need to label. And so we're going to label this minus 3 over here, and then we're going to label the turning point 1 minus 2. And then the last step is we're going to label the graph, and it's going to be labeled K. And that's it, guys. This graph never cuts the x-axis. So, and that's what I'm trying to show you, that my process works no matter what. Okay. So take a screenshot. We're going to have a break in a moment, and then we're going to carry on and do another example like this. And trust me, even like quadratic patterns, if you just come back and do another one, this will get so easy, guys. You just have to give it time. If you're feeling overwhelmed, don't feel stressed. Just a bit more practice. Okay. Take a screenshot now if you need to of the working out. And then we're going to take a brain break. And after our brain break, we are going to come back and smash the next example.
Yeah, I think Andrella, is that a question or it was to answer?
Okay. I'm showing the whole page so that you guys can you can see it. And then, guys, what I want you is I want your webcams on, and I want you to stand up and stretch. And I'm going to do the same. And Yolanda is going to give us points out of 10 for enthusiasm, artistic merit, all these good things.
Let's go, everybody. Let's go. Andrella, I want to see you stretching.
Let's stretch. Cameron, you just need to be careful. A slow stretch.
Zukanye, let's do this.
Slow stretch.
Zukanye, I see you. Kelly, you're doing it, girl. You're doing it. It will help you. Ambate, Mbiwe. Therefore, let's do it.
So, brain break. Here's a quick brain break. There's a donkey and a bird and a cow, and they walk into a barn. No, I'm joking. It's just it's a cow, a donkey times a bird minus a cow. Let's do this. Let's do this.
Yeah, you guys are on fire. That was so fast.
So this bird is clearly going to be 10. And oh my gosh, you guys are too fast. Okay. What I'm seeing is that a donkey is 5. And then each cow is 1, or if that's a cow. So we've got 5 times 10 minus 1. And the final answer, guys, is 49.
I think that this one was so easy for the grade 11s. They didn't even sweat. Yeah. They were just giving the correct answer.
I want to challenge them to do a Maths 24 question now. So I want to challenge you. Can you solve this Maths 24 puzzle as a brain break? This will get your brain turning a little bit, just to give you a distraction for a moment. When are we doing the cup challenge? Rachel, it's coming back when you least expect it, I promise. But for now, we are just going to stretch it out. We will bring back.
The horse is not going to rest until you bring it back. Hashtag bring back cup quiz.
Okay, let's see if we can solve this Maths 24 and we'll go from there. Who's helping me out here, guys? How do we get to 24 using 2, 7, 4, and 5?
Brain stretch, guys. Let's go.
So Muzia said 5 plus 7 gets us to 12, and that's a good way to start. So 5 plus 7 is 12. I think Muzi, I think you have got it. Let's have a look there. Who else can do this one? Okay. Any ideas, guys? So 5 plus 7 is 12. And then we can divide by 2. We'll get 6. And then 6 times 4 is 24. And so that's our Maths 24 puzzle. So in Izole, we're trying to get to 24 using the 4 numbers. Okay, guys, I see Tabelo and Sarah have put alternative answers in there. So thanks, guys. That was awesome. Let's get back to sketching. I want to spend some quality time with this sketching. What I want to do is I want you to do the 5 steps for this parabola. Once you've done the 5 steps, we will try and draw them. Okay. But I want you to put your answers for the 5 steps as we go. Okay, over to you guys.
Can we just zoom in the question like this? We can.
Yes.
Thank you.
Let's make this parabola as big as it can be. How's that?
That's perfect.
Okay, so we're going to draw this using the 5-step process. Is there a reward? Kamokelo, your reward is the absolute awesome feeling that you know when you see this in exam, you've got like 5 or 6 marks in the bag. Okay, so I agree. This is an unhappy parabola. It must be cold. So step 1, unhappy parabola.
Definitely, I feel like that. It's so cold.
Exactly. Oh, fancy words, concave down. Goodness gracious. That's a big word you've got going on there. Oh, she was saying about the cup quiz. When you say the cup quiz, do you remember, are you talking about, yeah, I was just checking that it's the same thing I'm thinking it is. Anyway, we'll come to that at another point. For the moment, we're going to keep our brains on the parabola. What's the y-intercept? Yeah, let's keep let's for the moment, let's let go of the chat and let's focus on the 5 steps. So y-intercept is 20. Now there's a bit more work for the x-intercept.
We can do this, guys. Let's go.
Do it.
See lots of faces focusing. Guys, I'm so proud of you.
Totally. Even on my face is focusing because I'm just making sure.
I agree.
I'm like, you see, my brain is working.
Yeah.
Delta, I was just praying delta wasn't another negative because I really wanted x-intercept in this question. So, but I mean, I'm more interested in the answers than I am delta. So let's see if someone can give me the answers in the chat. It does look like delta is positive. Maybe we'll just do it in one step. So -8. Yeah, I think sometimes it is quicker to just put everything into the formula at once. It just depends on the question. I don't get x is undefined. So for those who are getting that, what I think is for a lot of students, doing the delta step is an important step along the way to making it easier. And so delta would just be 8 squared for yeah, so my delta value is 224, which means my x-intercepts are going to be basically -8 plus square root 224. Yeah, we get decimals. You should be getting decimals, guys. So I'm going to put into my calculator -8 plus the square root of 224, and then it's going to be divided by -4, and you should get -1.74 for the one root. And then for the other one, you should be getting 5.74. Are you guys getting that? So again, I don't want you to be, the delta is an intermediate step. Basically, when I work out delta, I just work out what goes inside the square root, but I still need to go -8 plus the square root divided by -4, -8 minus the square root of 224 divided by that. Okay, so my x-intercepts are going to be -1.74, or x is 5.74. What is my axis of symmetry? So minus b over 2a is -8 over 2 minus 2 So I get -8 over -4. I get 4. No, I'm lying. Sorry. I get 2. I get 2. And how do I get my full turning point? It's not wrong to leave it in surd form, but I often leave my x-intercepts rounded to 2 decimal places. Okay. So guys, I'm going to use, if you sub it incorrectly, you're going to get 28 as the correct answer. And so your turning point should be 228. Now, I want you to take 2 minutes and try and draw the graph before I do it. You've got all the important information. You know it's an unhappy graph. You know that its y-intercept is 20. You know its x-intercepts are this. You know the axis of symmetry is here. And you know the full turning point. I want you to feel that great joy of drawing a sketch graph using the 5-step process. So it's over to you guys now. If you have a question, guys, though, please raise your hand and we will answer you. We can have a discussion. We can even work through it together. But for the moment, I want you to try and do it yourself. And then if anybody needs all the working out for the x-intercepts, I'm going to make that disappear soon because I need space to draw my graph. And so if you need to take a screenshot of this working out. Okay. Okay, so it's going to disappear in 3, 2, 1. Next stop is to draw a graph, which everyone is doing at the moment.
I would like to see actually the learner's graphs so we can tell which one is getting marks. Because there's tricky things that you shouldn't leave out.
Yeah. And also this has got quite a lot of detail. So I want to see, do they remember the process that we were following? So how did I get 28? I took the 2 and I put it back in the original equation. So it's almost like we would go -2, 2 squared, plus 8 times 2 plus 20. Does that help? And so if you look at this, this ends up being -8 plus 16 plus 20, which gives me 28. Okay. Now, I always like to draw myself an axis of symmetry, just to kind of get my bearings. How did I find the 20 in the y-intercept? Whenever we are finding the y-intercept, we always make x 0. And so what you see is that when you make x 0, it knocks this out, and all you're left with is 20. And so that's why we know g of x is just another way of saying y equals. And so that's how I knew straight away the y-intercept is 20. As Yolanda has said perfectly, you make x 0. I'll give you a little bit more time. Guys, when you have finished your graph, won't you just type in the chat finished? I want to give you enough time to do this without rushing, but at the same time, I don't really know how it's going. So just
can they
type.
also show us if that's possible on the screen? I would like to see your graphs. I have fun looking at people's graphs. Oh, a lot of people are finished.
Yeah. No, so we'll give a little bit more time and then I'll go through and do it. So let's go with this -1.
Okay. Kamu, you can show us. Kamu, hello. Show us on the screen. Let's see.
Let's see it. 20. Okay. Let's go with, okay, that should be approximately. Okay, my scale is not going to be perfect for this graph, but it's a sketch graph, so the scale doesn't have to be perfect. It just needs to be representational. Okay, Kamogelo, one of the challenges here is that the scale of the graph basically, yeah. Okay, let me go through it and I'll explain. So what I do is I've made marks for my x-intercepts over here. I've made marks for my y-intercept. Now, your graph may look a bit wonky because the distance over here is meant to be 20 for the y-intercept. And obviously, if the scale was better, I would make my graph bigger. But as long as this doesn't have to be a perfect graph, it just has to be approximately correct. So I know that 28, which is the turning point, it should be above the y-intercept, but it's not perfectly scaled because it's a sketch graph. Okay, so I've plotted my points, and now I'm going to draw an unhappy graph through these points. So I start down here, and I go through my x, I go through my y, and I've done one half. And then the other half, now guys, okay, I should be drawing this with a bit more curvature. Let me see if I can do that a bit better. There. That looks a bit more like a parabola. Now, guys, these are not straight line graphs. They are curved graphs. And basically, we're just doing an approximation of them. Now, obviously, it's a little bit easier on paper. Can you see my 4 points? Okay, and then the last step is I need to label. So I'm labeling this 20. I'm labeling this minus 1.74. I'm labeling this 5.74. And then my turning point, I'm labeling the whole thing 228, and the function is called the function g, and that is 6 marks in the bag. Give me a feel, guys. I want to squeeze in one more tonight. How did that feel? Give a thumbs up if it was okay to good. Give us a thumbs down if you still feel very lost. I just want to get a feel for the group. We're going to do one more tonight.
I saw some of the graph students. You guys did really well. You learned it. You know, no one fell for that trap that I was having in my mind. Well done, guys. Well
Take
done.
a screenshot if you need one, and let's do one more to finish today. Let's do, in the next lesson, we'll talk about the alternative form. Oh, that's a bit of a, let me draw it actually. Okay, here's the graph that you are going to sketch for me. The last one for today is going to be that. So y equals minus x squared plus 4x minus 3. Let me just move this out the way, and I'll move that up. So 5 steps, working over to you guys. Let's get the show on the road. Draw me that graph, do the 5 steps and draw it, and over to you. I will give you a little bit of guidance by including some of the important information that might help you. But it is over to you guys. Okay, it is. We have a lot of sad parabolas today. Alas, it must be the weather. And y-intercept, I think most of us can see. If you make x 0, you get the y-intercept. And so these get knocked out, and your y-intercept will be minus 3. Yes, we're doing another one now. So this is our last one for the evening. We're just going to squeeze in one more, and then we're going to go off and do our quiz. Because it gets a little bit easier each time you do this. So for the x-intercept, I want to make y naught. Now I think I'm not going to use the formula this time. I'm going to be a little bit sneaky and use factorizing because I think I can factorize this one. But the formula will give you exactly the same answer. So okay, so those who have used the formula, you should be getting 2 values for x. You should get 2 values for x. So don't forget that if you use the formula, and most of the time I would recommend the formula. The only reason I did it by factorizing now was because basically I could see I could factorize it and time was running out. X squared, yeah. But remember when you're doing the formula, you don't just have a plus square root, you also have a minus square root. So you get x is 3 and x is 1 as your x-intercepts. And I know some of you, I may have rushed you a little bit there, but just so that we can draw the graph, I will give you the answer x is 3 and x is 1 for the x-intercepts. I want to know my axis of symmetry, and I want to know my turning point. And then I want to see some beautiful graphs. Okay, there's a little bit of a debate about the turning point. Most of us are saying something similar for the axis of symmetry. So minus b, so minus 4. Yeah, I get x is 2 for my axis of symmetry. But what's my turning point? Minus something squared plus. I get 1. And so guys, my turning point is going to be 2, 1. So that's all the information you need to draw the graph. I want you to try and draw that graph for me, just to squeeze it in before we end tonight. Actually,
Nakoso's calculator has a virus.
no. Now, guys, you would normally have more time than that. It's just that we are just trying to squeeze this example in before we finish. See if you can draw the graph now using that information. What does your graph look like? Yeah.
Okay, done with your graph. Ooh, Rachel is done with the graph. I see you, Rachel.
Hold up that graph for us to see.
Katleho, I see yours also. Remember to label, guys. You need to name your graph.
Yeah. Don't forget to label. So what is x is 2 is a very popular axis of symmetry. Geez, it seems to be coming up in like every question. Anyway, x is 2. I label my axis of symmetry first. Now it's time to put some dots in. 1, 2, 3. That's my y-intercept. My x is at 3 and 1. And where is my turning point? My turning point is at 2, 1. And so we get that. And then I have to fit it in. And it's an unhappy graph, which makes sense. Okay, that looks a little bit too much like a, let me change my scale a little bit so I have a bit more room to be pretty in. So like that. Oh, guys, sorry. It's not the prettiest parabola I've ever drawn. But basically...
That's perfect, though. That's perfect.
So we've got my dots. And the last part is we need to label. So we know this is -3. We know this is 1. We know that is 3. And we know the turning point is 2, 1. And then the last little bit is we label y equals -x² plus 4x minus 3. Okay, now we're going a little bit faster in that last bit, but I think most students will see by now that the process of drawing a parabola is very systematic. It's just these 5 steps, and you just practice, practice, practice. And we will continue a little bit with this in the next lesson, so don't worry, there is still more practice to come. But guys, I just want to say it's been fun from tonight. Give us a thumbs up if you feel like you could draw parabolas. Give us a thumbs down if you feel like not feeling so good about that. And then Yolanda, if you could put the link to the quiz in the chat so that students can go off and do it. Okay. But yeah, be honest. I just want to see in the chat. It helps me know for the next lesson how much more repetition to do. Okay.